Hey everyone, in this video we are going to look at one-sided limits. So sometimes it doesn't just say as the limit as x approaches 2, for example. Sometimes it'll say the limit as x approaches a certain value from the left. So this little minus sign indicates the left. And then the other way they'll do it is they'll put a plus sign up. It's basically kind of like the exponent, and that means to the right. Sorry, it's supposed to be an arrow. So if you have a little plus sign as the exponent for your value, that's saying the limit is approaching that value from the right. And then if you've got a minus sign as the exponent, that's saying the limit as x approaches that value from the left. So here from the left, we're saying, when I think of left, if this c is my value, I'm thinking about as my function is approaching that x value from the left, versus here, how the function is approaching that value from the right. So think about it as starting at the right side of the graph, and heading towards that value, and then starting at the left side of the graph and heading towards that value. So you're thinking of the left and the right of whatever x value they give you. So the theorem that we have for this is if the limit from the left equals the limit as x approaches the value from the right, then the limit is, if those both equal the same value, so say like here they both equal L, then the limit as x approaches c, so not from the left or from the right, but just in general, will also equal L. So you have to be approaching the same value from the left and from the right in order for the limit to also equal that value. On the flip side, if the left and the right side don't equal each other, so here this is approaching it from the left, so you can see it's coming towards c from the left direction, and then here it's coming at c from the right direction. Those two values are different. So maybe this one hit at 3, this one hit at 1. So because those values are not equal, then the limit does not exist. So if we just say the limit as x approaches c of that function, it is not going to exist. So remember, DNE means does not exist. So putting that into play, we sometimes see that as a table or algebraically, and then sometimes we see it as a graph. So looking at it from a table, if I were to say the limit as x approaches 0 from the left of this function, one way you could approach it is you could plug into your calculator a bunch of values that are getting close to 0 on the left. So to the left of 0 are negative numbers, so you can see I'm picking x values that are getting closer and closer to 0 from the negative side. So in my calculator, when I plugged those in, for the first one I got negative 20, then I got negative 200, then negative 2,000, then negative 20,000. So that value is just getting smaller and smaller and smaller. It's going more towards the negative infinity. So this limit actually does not exist, and that's because it's going towards a negative infinity. When I evaluate it from the right, so if I do x approaches 0 from the right side now, I'm picking positive numbers that are getting closer and closer to 0. So you can see my decimals are getting really, really small. So when I evaluated those, my calculator told me 0, 0, 0, and 0. So this function, when I'm getting close to 0 from the right, is approaching 0. So because the limit when my x approached 0 from the left does not equal, let's say this a different way. My left limit and my right limit were not equal. The left one was does not exist going to negative infinity, and the right one is 0. So that way we can conclude that the limit of f of x as x approaches 0 just straight up does not exist. And I'm calling this function f of x. So the left and the right side weren't equal, function does not exist. Graphically, how we could look at it is I've got an example like x approaches 1 from the right. So I find 1, so here's 1, and I look at the graph approaching it from the right direction. So the y value as I approach from the right is going to equal 0. Even though there's a hole there, that's the number it's getting close to, so that's still going to equal 0. Then as I approach 1 from the left, here's x equals 1, but I've got to look for where the function is approaching from the left, and that would be this side of the graph down here. So as I'm approaching it from the left, the y value that I'm hitting at is negative 4. Even though there's a hole there, it's still getting close to negative 4, so we say negative 4. So when it asks x approaches 1, not from the left or right, just in general, these two values were not equal, and you can see on the graph there's a jump here, so that limit is not going to exist. So it does not exist. Let's do one more with 4. So as x approaches 4 from the right, so 1, 2, 3, 4. So here's our x is 4. So approaching it from the right, we're hitting a y equals 2. Approaching from the left, we're also a y equals 2. So both sides, the left and the right, meet at the same spot. So the limit of f of x as x approaches 4 is 2. Finally, we can look at it algebraically. So this function, if I said the limit of 2x minus 5 as x approaches 3 from the left. So you could graph it if you want to do it that way, but I bet you all can picture this graph and you know that this function is linear. It's just going to be a line. So there aren't any jumps in the line. So what we have to do is we can just plug 3 in for x. So you can just do 2 times 3 minus 5. So 6 minus 5 is 1. So that limit is 1. Here, you guys learned last time that if you plug in 1 and you get 0 in the denominator, you have to do a little bit more work to try to figure out how to evaluate it. So what I'm going to do is, looking at the top, I can see that those have an x in common. So I'm going to factor out an x. And then I still can't do anything. So I notice that this is difference of squares. So I'm going to factor it again. So that's going to be x plus 1, x minus 1. And that's still all over x minus 1. So that means there's going to be a hole at this x minus 1. So I can eliminate them. So what I'm left with is I can plug in this 1 value in for my x's. So it'll look like 1 times 1 plus 1. So my limit here is going to equal 2. Finally, the special one that really matters for the left and the right is going to be when we have absolute values. So absolute values are a little bit different. So here we have to think about as x approaches 2 from the left. So I usually do it, I'm just going to show you both ways. So when x is greater than 2, those are values that are to the right of 2. And when x is less than 2, those are numbers that are to the left of 2. So when I evaluate values that are greater than 2, so maybe I plug in a 3. So 3 minus 2, I'd get 1 over 1, which is 1. If I do 5, we'd get 3 over 3, which is still 1. So when x is greater than 2, our limit is going to be going to the value 1. So the limit is going to 1. And then from the left, when x is less than 2, so if I pick value 1 maybe. So 1 minus 2 is negative 1. So I'm just going to practice plugging in 1. So I'd get negative 1 over 1, which is negative 1. If I plug in 0, you'd get negative 2 over 2. So anytime you plug in a number less than 2, this function is going to go to negative 1. So that means our limit as x approaches 2 from the left, so for all values less than 2, this function is going to go to negative 1. But if this had been a plus sign and going to the right, then our answer would have been 1 instead. And you now know that if I had just done the limit as x goes to 2 without saying left or right, it would not exist because the two sides are hitting at 2 different values. All right, that's it for this. So why don't you guys try the practice problems and see how they go.